Hi everyone. In this video we will focus on the topic of compound interest. When is simple interest used? Situations involving simple interest are fairly rare and usually occur when money is loaned or borrowed for a short period of time. More often, interest payments are made in periodic installments during the life of the investment. The interest payments are credited to the account periodically, and future interest is earned not only on the original principal, but also on the interest earned to date. Compound interest is paid on the principal and on the interest that the account has already earned. So compound interest includes interest on the interest. Let's return to that $1,000 investment earning 10% per year. But this time, let's assume the interest is compounded annually at the end of each year. So at the end of the first year, again, we would earn 10% of the amount in the account, $1,000. So at the end of the first year, we have $100 worth of interest. And the new balance in the account would be the $1,000 invested plus our $100 in interest, so $1,100. Now, because our interest is compounding annually, in the second year, we'll be drawing interest not only on that initial investment of $1,000, but on our new balance in the account, the $1,100. So our second year's interest will earn 10% of the balance in the account, the $1,100. So our second year's interest would be $110, and the balance at the end of year 2 would be $1,210. In the third year, we'll draw interest on the balance at the end of year 2. So 10% of our $1,210 or $121, and the balance at the end of year 3 would be the balance at the end of year 2 plus the interest earned over the course of the third year, so $1,331. Now for comparison, we can use the simple interest formula to find out the simple interest earned after 3 years. For simple interest, we take the principal P times the rate R times the time 3, and see we get $300 worth of simple interest, which would give us a balance in our account of $1,300. Compare that to our compounding interest, where we had a balance of $1,331. Not a huge difference. We'll say more about that in just a moment. As a basic rule of thumb, interest earned on an account with compounding interest is always at least as much as that earned from simple interest. If the money is invested for a short time, simple interest can be used as a rough estimate. But let's get back to the comparison. Here's our investment of $1,000, earning 10% interest every year. In the case of simple interest, because we're only getting interest on that initial principal amount, then every single year our account will be growing by the same amount of $100. With compounding interest, because we're earning interest not only on the initial amount, but also on any interest earned to date, we see more growth. In the short term, after only 3 years, we saw there wasn't a huge difference between simple versus compounding interest. However, if we allow this money to remain in the account over a long period of time, we can see a tremendous difference. Look at the year 50 mark, the difference between $6,000 and $117,000. That's quite the difference. For simple interest, the balance is growing by the same amount, in this case $100 each year. And this means that the balance for simple interest is showing linear growth. For compound interest, the balance is growing by the same percent, 10% each year. And this means that the balance for compounding interest is growing exponentially. Here's a visual. Suppose we invest the same amount of money at 8% interest for 40 years. The blue line shows the future value of the account under simple interest. The red curve, the exponential curve, shows the future value of the account under compounding interest. you see at the 30-year mark the difference between $340 in value and a little over $1,000 in value. So how do we compute compound interest? Recall, compound interest is paid on both the principal and on the accumulated interest. And here's our formula. A equals P times 1 plus R over M to the MT, where A is the amount earned after interest is made, P is that principal investment, R is the interest rate, M is the number of times the interest is compounded per year, and T is the time of the loan in years. Let's look at some examples. Suppose we invest $10,000 in a 5-year certificate of deposit, a CD, that pays an APR of 6%. What is the value of the mature CD if interest is compounded annually, quarterly, monthly, or daily? If the interest is compounded annually, then using our formula, we see A is equal to the principal of $10,000 times 1 plus our interest rate of 6%. If interest is compounded annually, then M will be 1, and T, the term of the investment, is 5 years. Putting this together, we see we'll end up with an amount in the account of $13,382.26. But what if the interest is compounded quarterly? Again, using our formula, A is the principal amount, $10,000, times 1 plus our interest rate of 6%. This time, since the money is compounded quarterly, the M will be 4 and T is still 5. We end up with $13,468.55. Notice the only difference between A and B is the value of M. If the interest is compounded monthly, then M will be 12. And if the interest is compounded daily, M will be 365. Notice, in all 4 cases, the only thing changing is the value of M, the number of times the money is compounding. Let's do a quick timeout for a discussion on calculators. Here's our generic formula and the specific equation that we had in the previous example. Now, students have a varying comfort level when it comes to using their calculator and various different types of calculators. I'm going to walk through what would happen in the case when you're using a very basic scientific calculator. And for a student who's really kind of uncomfortable with the calculator, who wants things really broken down in a step-by-step fashion, if you're someone who has more comfort with calculators, more comfort with parentheses in particular, then you can certainly go through this computation in a much faster and slick method. I'm just going to, again, do it in a very step-by-step fashion for students who find that helpful. We're going to start with the R over M. So you would first type into your calculator, in this example, 0.06 divided by 365 and hit enter. Then add the 1. So you would type into your calculator plus 1 and hit enter. Now we're going to deal with the exponent, the MT. Type into your calculator the caret button. This will get you into the exponent. And then in parentheses, 365 times 5 and hit enter. Be sure that the 365 times 5 is in parentheses, that all of the MT is in the exponent. Finally, multiply by P. In this example, you would type into your calculator times 10,000 and hit enter. You should, in this case, get the same answer we got, $13,498.26. Now, the last example was about CDs. Some pros of CDs are the safety. The money is insured up to $250,000 by the U.S. Federal Deposit Insurance Corporation. And the reliability. The money will earn a set interest rate. You aren't at the mercy of the market. The cons are low returns. The rates are low. Advisors recommend them only for a short term, and for the long haul suggest you consider mutual funds. And there's a lack of liquidity. If you withdraw money before the CD matures, you pay high penalties. Here's an example that you might pause the video and try on your own, practicing using your calculator. See if you get the same answer that I got. We're going to spend our time on 2 other examples that are a little bit different than the ones we've done so far. Suppose you invest $200 at 5% interest compounded daily for 10 years. How much interest do you earn? Well, using our formula, we see that the amount in the account will be the principal of $200 times 1 plus our interest rate of 5% divided by 365, since our money is compounded daily, to the exponent of 365 times 10. So the amount in the account will be $329.73. But we want to know how much interest is earned. And this amount includes our initial investment of $200. So the interest earned would be the amount in the account minus our principal amount of $200. So the interest earned would only be $129.73. Suppose you invest in an account earning 6% interest compounded monthly. You would like your investment to grow to $1,000 in 10 years. How much would you have to invest in order for this to happen? Since the money is compounded monthly, we'll use our compounding formula, but we have to be a little bit careful here. We want our investment to grow to $1,000. That's telling us our final amount, A, will be $1,000. And we want to know how much we have to invest initially. So in this example, we're looking for the principal P. Our interest rate is 6%. Our money is compounding monthly. And we want it to sit in the bank for 10 years. So we do the computation in our calculator. And then we're going to divide 1,000 by 1.819396. And see, the principal amount we need to invest is $549.63. Here's a final example similar to that last one, where you want to know what needs to be invested initially in order to have $10,000 eventually. You may pause the video and try it on your own. See if you get the same answer that we got. That's all for now. Thanks, guys.